Hello guys, so on our series of statistics, so today I wanted us to tackle some a bit of conditional probabilities where you're given some probability density function, then you're being told to get the conditional probabilities and so on and so on. So we have a question, I have a question here that is saying that an analyst has modeled the loss in units of 1,000 pounds. So due to a fire in a supermarket using what we random variable x with a probability density function of the form that you can see on the screen, a into bracket x is equals to 20 for the value of x lies between 0 and 20. So the first question is you're supposed to determine the value of a, where a is a real number. Then number two, you're being told to calculate the conditional probability that the fire loss exceeds that 16,000 pounds, given that it exceeds 8,000. So we can dive into our solution. So part one. So you can come here on the ribbon, then you can just come here and choose the Roman number that you want. Since 1, so it can be Roman 1. So this Roman 1 will be a solution. So we put our solution. But already remember that we have been given our probability density function. So we can insert our equation editor. So we know that f of x is equals to a into bracket x is equals to x minus 20, where we've been given that the value of x lies between 0 and 20. Yeah? So the value of x lies between 0 and 20. So that is our limit. Then you've been told that you determine the value of a. Remember that for any probability distribution function, when you integrate the whole PDF, the whole probability density function under the curve, you will just come, it is always is equals to 1. So anytime you're doing your integral, you will have to integrate it with respect to that. So we equate it to 1 and then we solve for the value of a. So we insert our equation editor. So here we are using integral. Yeah? So you have to insert your equation editor, then you use your backslash, and then you use int. So int, we can decide to we can put the limit. Yeah. So the underscore normally puts the lower limit, and then the rest power puts for you the upper limit. Yeah. So we find that the value of x lies between 0 and 20. Yeah. 0 and 20. Sorry. Yeah, 0 and 20. Then we have our value of a inside the bracket. We have x minus 20. We are integrating it under the curve. Yeah? So the whole of this we equate it to 1. Yeah? So we insert our equation editor, that, and then just a moment. Yeah. So a will be outside, and then we will still remain with our integral of from 0 raised to power 20. So now into bracket we have x minus 20 with we are integrating it with respect to x. Okay, right? So we just go to the next line and then we start another equation editor. So now we are integrating what we have inside the bracket. So what we have is x raised to power 2. So we integrate x, then we divide it by 2. Then minus 20, then minus 20, x, yeah, because it didn't have the value of x, yeah. So you close it, but don't forget to put the limits. Yeah? So remember we have the limits both from 0 to 20. And then remember that you're still equating everything to 1. Yeah? But don't forget that we have our value of a here. So you can subtract the upper limit with the lower limit. Yeah? So a, open the bracket, and then you can replace it with that. So 20 squared, that is 400. 400 divided by 2, that is 200, minus our value of 20 times 20, 400, yeah. 20 times 20, that is 400. 400, yeah, that is 400. Then you see that everything for the lower limit, everything is going to be 0. So all of this, you're going to equate it to 1. So it means that you will have a into brackets negative 200. So that's what you have, which is equals to 1. So it means that at the end of the day, our value of a is equals to negative 1 over 100. So that is your value of a. So just know that anytime you are integrating the area under the curve, so make sure to equate it to 1 and be careful of the limits that you've been given. Now let's go to the second question. So Roman 2. So we go to solution here. So remember that question 2 was saying that calculate the conditional probability that the fire loss exceeds 16,000, given that it has already exceeded 8,000. Yeah. So what you need to apply here, we have something that we call the memoryless property. Yeah, memoryless property. So this means that we are having our conditional probability. So here we are calculating the probability of x exceeding x plus n, given that x is greater than x. So this is our conditional probability that we are trying to calculate, which in the real sense means that we can open our bracket. We have p into bracket. So this is x, which is greater than x plus n. X plus n divided by close open the bracket, put p into bracket. X is greater than small n. Yeah. So at the end of the day, you have something like that. So in simple terms, what we are trying to say is that we'll have, if we split the probabilities, we split the probabilities that we are having, whereby x is greater than x plus n. So this is probability of that of x plus n, then probability of into bracket x is greater than n, then we divide it by the probability of p being greater than small I. Just a moment, close here and close here. So you'll have something of this sort. So you remember that you see that at the end of the day, when we get our pen somewhere here, we're just going to cancel this and this. So it means that at the end of the day, you're going to remain with probability of x being greater than x. So remember that now what we are trying to calculate is so we are now calculating the probability x exceeding 16,000. So we are now given that it has already exceeded 8,000. Yeah. So this is p into bracket x is greater than 8,000. So we close here. Just want to put another bracket here so that we can have a very beautiful equation like that. Yeah? So that's what we need to calculate at the end of the day. Yeah. Then I know someone might be asking, so our value of x is 8,000 and our value of n is 8,000. Yeah, because it was already at x, but now it has exceeded 16,000, 8,000. So here we are doing the integral. So we start for the 16,000 for the 16,000. So remember that we have already calculated our value of a. We know that a is equals to our value of a has already we have already calculated our value of a. Yeah? So our value of a is equals to negative 1 over 200. So what you need to do is that you need to complete your probability density function of f of x, which is equals to negative 1 over 200 sorry for that, 200, sorry, backslash 200 into brackets. Remember we had x minus 20, so that is our f of x. So for the 16,000 we will do integral, so backslash of the int. Remember now we have the new limits. Remember the maximum limit was 20, but now we have 16. So our lower limit is going to be 16 and our upper limit is going to be 20. Then the same case here, we'll have to negative 1 over 200 because that's your probability density function, and then x minus 20. Remember that we are integrating it with respect to x. So using our advanced calculators, I'll share a video on this. There is the way you can fit this value in your calculator to save your time in exam. So this is 16. I'll just place everything direct. So here I have negative 1 over 200, and then I just multiply it by into bracket, and then I put alpha x minus 20. So that one will save me a lot of time. So that one I'm getting 1 over 25. So please make sure to get that answer, 1 over 25. So the next one is for 80 for the 8,000. So for the 18,000 limit, so the same way you insert your equation editor, you just write int, your lower limit is going to be 8, your upper limit is going to be 20. Sorry, so that one is your upper limit is going to be 20. So remember here still you're using the same probability density function, and then in the bracket you are having x minus 20, then bring it with respect to dx. So for me, I'll just replace it direct here with from 16 with 8, and for my calculator I'm getting 9 over 25. 9 over 25. Yeah, so that is it. So but this one you can convert it into decimal point, maybe for proper division. This one I'm getting 0.36. This one 25 inverse, that is 0 is equal to 0.04. Now remember our question was to calculate the probability that x exceeds 16,000 given that it has already exceeded 8,000. So it becomes very simple now. So your work is just to insert the respective values and then you divide it. So 0.04, and then you divide it with 0.36. So that is it. So we'll have our answer as 0.3. Let me divide. I'm getting 0.1111. Yeah. So that will be your conditional probability. Given that the conditional probability that the fire loss exceeds 16,000, given that it exceeds 8,000. Yeah.